Hello everyone, in this video I am going to teach you how to open an assembly language code and how to code an ARM LPC1768 processor in its assembly language mode. Last video I have explained to you how to open the Keel IDE and how to create a project and how to open the startup code for that particular project. Now let us see how to write a basic assembly language code and how to run it in this Keel IDE environment. So let us start with the first line of my program. This is a small program which explains the different arithmetic and logic operations which we can do using the LPC1768. So any program, any assembly language program, the first starting line of the assembly level program is nothing but you start with the keyword area. So all keywords you can see it is having a blue color in this program, as you can see. So area is nothing but it defines the memory region where you are going to store the code and store the data. Any programming language, whenever we write a program, the program is being stored inside the memory, that all of us know. So which part of the memory is going to act as code memory and which part of the memory should be allocated for data memory, all that is being done by this keyword area. And we give a name for the particular area, that is for this program we just give a space in the memory called as basic. You can define it by any name you want. And then we are defining the code, this memory basic is going to store the code which we are going to write below. And then this word is optional, read only is optional. You can have the code as read only or you can also change the lines inside. So just here it is given as read only, means you cannot change the lines, or anybody who reads these lines cannot change it. So that means read only. Then the next keyword is going to be entry. So this says that the following lines will be taken for execution into the processor. So entry is a keyword which tells the processor or the compiler to take the following lines as code and run it inside the processor. Next keyword is called as export. So export does the process of assigning the program to the particular memory location. So which memory location will it allocate the program into? That is given by a label called as main here, but you can give any name you want. But for the compiler to understand this as a label, you just have to give a double underscore followed by a label name. Next, export is a keyword which is used for allocating a memory location for the given label. Initially, you do not know which memory location is free, so you just give a label. Then under the label, whatever you write will be taken as a code and it will be stored inside the memory location which is allocated to this label called main. Again, I am mentioning main is not going to be a keyword. You can give any name you want there. But double underscore is important. So export double underscore followed by any name you can give. That is nothing but the label to which a memory location is being allocated during compilation. So next we start the coding under this particular label double underscore main. So in the coding you can see I have used the different registers which are available in LPC1768 starting from R0 to R8. So these registers I have used R0 to R8, 9 registers I have used for my operations. And the different arithmetic and logic operations you can see over here: addition, subtraction, multiplication, division and OR and XOR. These are the operations I am going to perform in this program. Next, the syntaxes, if you see, you have to have add followed by the register, the destination register, and followed by the two source registers where you have the two data. For addition, you know, you need to have two data to be added and the answer should be stored in a particular register. So R0 and R1 will hold the values, two values to be added, which is stored in the register R2. Similarly, subtraction operation, you give the same two numbers or the different numbers in R0 and R1, and the answer you get it in register R3. Similarly, multiplication, the destination register is R4. For division, it is going to be R5. For AND operation R6, OR operation R7, and XOR operation R8. Then we end the program using this self loop, that is B stands for branching and L1 stands for label. Then the last is the end of the program. Now we have created the program. Then what we are supposed to do? We are supposed to go to File, Save As. So you can choose the same folder wherever you are having the key, wherever it shows, followed by a name. So here I have given it as arithmetic. So arithmetic, so already, and we are going to save it as .s file, arithmetic .s file. I am going to save it. So this is going to be arith.s, that is the name I have given for this file, and I have saved it as .s file. .s file is .asm file. So now we have created the program. Then the next step is you are supposed to add this program to this header file or the source group. So you go to source group and you right click source group, and you can see add files to group source group 1. So you just click that and then go to your file type. You have to choose ASM. You have different types of files. I am choosing the ASM source file here because I have saved it with the extension of .s. Then I go to my program which I have saved. It is arith.s. I am just adding that program. You can see in below source group 1, this arith.s has been added. Our program has been added, so you can close it. Once you are done with this, the next step is you will have to open the header file and make some changes so that this program will be run properly. So I am going to the startup code, and in the startup code I am going to line number 121. So in line number 121 I am just writing import. So in the program you can see I have given a export keyword, and so in the startup code is the header file for this particular program. So I am just writing a keyword import followed by a space, then double underscore MAIN, that is the label which I have given in this arithmetic program, export main. Similarly, in the startup code I am just giving import main. So now I have included that label inside this startup code. Next, what we have to do is we have to comment certain lines from line number 127 to line number 130. We are supposed to comment those lines. For commenting we use semicolon. So I am just commenting lines 127 to 130. So it means I am not going to use the system init handler. I am just going to use my label MAIN. So it is case sensitive, so I am just changing it as capital MAIN because import MAIN is my label. Similarly, what does this underscore main have? It contains the address. Actually, it is the label for a particular address. So that address is loaded into a register R0. So LDR is load register R0 with the address of the main. Main is nothing but the label which is being written in the code, because initially while we write the code we do not know what is the address which is being allocated, so we put it as a label. Then the address, while compilation, this the compiler will allocate addresses, so that address will be copied into R0. The next step, BX R0 is, it is nothing but BX is the link register, or it is an indirect register. R0 points to an address and that is being taken by this BX branching, the R0, the address pointed to by R0 is being reached using this instruction. So accordingly the program will start running from this start address which is pointed to by the register R0. So these are the steps that we must perform before running our program. Next, two more steps we have. So go to line number 272. Import use 2 region memory. I'm going to comment that line. And 273 export initial stack heap. I'm not going to use these two. Stack I'm not going to use. I'm not going to use 2 region memory. Both my data and code is written in the same region of memory. So these 2 lines I'm commenting. So I'm going to use my heap memory for the remaining application. So we are done with the startup code. Now what I'm going to do, I'm going to go to project and build target. So you can see there are 0 errors and 0 warnings in my editor. So you can see after compilation it shows 0 errors, 0 warning. Now we'll go for debugging the program. So debug, start the debug session. So it asks running with code size limit 32K, okay. Now next step is, you can see the register window which is opening on the left hand side, and you can see the assembler window which is shown over here. This is the assembler window. For each line you write here, your assembler window opens. So for each line you write here, this is the assembly line which is being executed in the assembler window, you can see. Now I'll show you the step-by-step execution of this program. So initially what we have done, we have loaded R0 register with data 4, and next second data we store it in R1, and that is given by 8. So 4 and 8 are the 2 numbers which we have loaded into R0 and R1. This is immediate addressing. Now let me show you how to run. So I am showing you step by step process of running. So step. So initially R0 is loaded with the address. So you can see the address 0x101. That is the starting address where our program is being stored. Then next step, what we are doing, we are moving the data, first data 04 into R0. So next step is, now you can see R0 has the value 04 into R0. The register R0 is having the value 04. Next what I am doing, I am running the next step. So the next line, that is move R1 comma hash 0x8, that line is getting executed. After execution you can see R1 register is having the value 8 stored inside the register. The next step is addition. You have to add the 2 numbers and store it in register R2. So the next step, I am executing the next line. I am adding 8 and 4. The answer is 12, and it is the hexadecimal value. C is the hexadecimal equivalent of 12, and that is being stored in the register R2, that is shown over here. Next, step by step I am executing subtraction. I am subtracting R1 comma R0. From R1 I am subtracting R0. So 8 minus 4 is 4, that is stored in R3. Next I do the multiplication. 8 4s are 32. The hexadecimal equivalent of 32 is 20. Next I do divide 8 divided by 4, and it is stored in register R5. So 8 divided by 4 is 2, and the answer is stored in R5. Next you can do the AND operation. AND operation, it is stored in R6. Next I do the OR operation, and the answer is stored in R7. You can just try the AND operation and the OR operation. And the next is XOR operation. The answer is stored again in R8. Now we are done with the execution of all lines and our program is exiting outside, and then that is the end of the program. So now I stop the debug session. Now I have got all answers in my registers. R0 has 4, R1 has 8. Those are the two data which we have given, and the arithmetic and logic operation answers are stored in the different registers. So this is how we execute the program. We write a program and we do changes in the startup code. Startup code is the header file which we have included for any program we do. Then we write the actual program or the code which we are going to run, and then we combine the startup, the header file as well as our code, and then we compile using build target. After compilation we check whether there are no errors. Then we confirm there are no errors, then go to debug. In debug we start the session. We are very well able to see the assembler, and then we are able to see the registers and where we are going to store the data and view the data. So then we can stop the debug session and come out. So in this video I have explained you how to write an assembly language program, how to compile it, and then how to run it, and finally how to see the answers. So the next video I will teach you how to, and in this program we have seen it is going to be immediate addressing, where we place the data immediately into the registers and do the operation. So there is a disadvantage in this, because only this program will work for only these two values, immediate values which we have given. In case you want to change the values during execution, then you can go for indirect addressing, where you store the data inside a memory and shift it into the registers while doing the operation, while doing the running. So that we will see in the next video. Happy teaching, happy learning. Thank you.